All right, so this is the second half of section 2.6 on implicit differentiation, and we're going to practice this method for differentiating implicitly. So the best thing to do would be to attempt any of these based on the part 1 video, but if you need another example or you want to see a little bit more first, that's fine. But at some point, please try to attempt some of these, press pause and do what you can, and then check your answers. That would give you the most knowledge. So let's take a look at A. Now, what's really important in A is that you have 3 terms, and all of them are separate, so they don't combine x's and y's, and that's really key, because without it, it's less work. We want to remember that with x cubed, it is just as we always would think, 3x squared. We're just taking the derivative of both sides. The issue comes in that, again, we did not solve this for y. We are going to take the derivative just as it is without having it as y equals. All that means is that when we take the derivative of y cubed, we have to use the chain rule here. The chain rule is needed, because we might want to say, oh, the derivative of y is 3y squared. But we have to remember that y is the dependent variable here. It's dependent on x, and that is something we assume, and we assume that y prime exists. So we have to take the derivative of y. That y is not, the derivative of y is not just 1, the derivative of y is y prime. And so it requires us to multiply by y prime. So we're using the chain rule in that piece. And then the derivative of x, just as you'd always think, is just 1. So there's pieces to this that are very, very normal and common, and then there are pieces to this that are more of a challenge and more work. So we have 3y squared times y prime, and our job now here is, it says find y prime, so I want to have an answer that is y prime equals. So I'm going to bring that 3x squared over using subtraction, and then you can probably guess the last step here in solving for y prime. It is division. And so we get y prime equals 1 minus 3x squared over 3y squared. So notice this derivative, this y prime, does have x and y in it, and that's okay. That is what implicit is. And if you know an x value for an equation, you can find the y value just by solving. And so if we needed to find the derivative at a certain point, we could do that. And we have an example of that actually in our last piece. So now we've got 3 pieces again, 1, 2, 3 in B. The first piece, totally normal. We've got 8x, that's it, just like we would normally. Now, the derivative of y cubed, we already had that in the last one, so we're using that chain rule there, 3y squared times y prime. The big difference here is that we have an x squared y. And the way you want to look at this is that it's x squared times y. That's what it is, x squared times y. So can you guess what rule we are going to need? The product rule, because of the multiplication. So it tells us, and I do it this way, I take the derivative of the first piece. So you want to look at this as one piece, which is x squared, and 2 pieces, the second piece is y. So we have the derivative of the first, which is 2x, times the second, which is y. Adding to that, the first piece, x squared, times the derivative of the second piece, which the derivative of y is not 1, it is y prime. So now we have everything laid out here, and we just need to solve it for y prime. So a key thing is anytime you see multiple y primes, so notice I have a y prime here, I have a y prime here. I have 2 terms with y prime and 2 terms without it. But I need to solve it for y prime, 1 y prime. So in a case like this, the key thing is to factor. Now I can't do that quite yet, But what I mean by that is I'm going to bring everything that has a y prime to one side. So I'm going to subtract the x squared and the y prime over from the right side. And then on my left side, I'm going to have 2xy, and I'm going to bring over the piece that does not have the y prime on the other side. And the reason I do this is because then I can factor out my y prime and see what I have left. 3y squared minus x squared. Now the reason for that is I just went from seeing 2 y primes in my equation to seeing 1 y prime in my equation. And because of that, we now know that our last step, look at my multiplication there, last step, division on both sides. So if you saw that, way to go. And that will give me y prime equals 2xy minus 8x over 3y squared minus x squared. And so that's solving for y prime. We have our answer there for y prime. And I always just have to make sure that my answers match my notes, because if I make a small mistake, it's now on video. Okay, so those are those two, and we have 2 more, so you can try them and pause and stuff and check. It's up to you where you're at right now. So this next one here for C requires what rule? We need the chain rule. So I think it will be easier than you might be anticipating. Notice we have y prime. I mean, if I take the derivative of y, I get y prime. You just have to understand that there's going to be another y prime. I don't have just one y prime here. So y prime equals derivative of sine is cosine. Keeping the inside the same, this is the chain rule from previous sections, and then we have to multiply by the derivative of the inside. Luckily, there's no product rule or quotient rule or anything crazy on the inside. We just take the derivative of 3x plus 4y, derivative of 3x, 3. Derivative of 4y is going to be 4 times the derivative of y prime. Now, some students, I have seen this in the past, may stop there, and they're just like, okay, well, I have it solved for y prime because I have y prime on the left-hand side. But you've got 2 y primes, so don't forget that there is another y prime in your life, and it is right here. And so because of that, you need to get both of those y primes on the same side. So this is really just another instance where factoring is going to come into play. But first, you have to go to an old school move, which is the distributive property. So we have a binomial here. So I'm going to take this binomial and I'm going to multiply both of the terms by this long cosine of something. So that I have 3 cosine 3x plus 4y. And then I would add to that 4y prime times my cosine 3x plus 4y. So it really, lengthens this thing, but it does allow us to have the y prime kind of by itself in a way, like it's not combined into this binomial, which is being multiplied by something. It's now just in a term. So what we'd have to do, like we did in the last example, is factor. So I'm going to have y prime minus 4y prime times the cosine. So I'm just bringing that to the left-hand side. And then my right-hand side, 3 cosine 3x plus 4y. And at this point, we can now factor out that y prime. So our goal, again, is to take the 2 y primes, make it 1 y prime, so that we can solve for y prime. So now I have 1 minus 4 cosine. And again, pause anytime, try to do some of this. That's going to create better knowledge in your head. And as we've seen already, this idea of division is really important in the end. So I'm just going to write that because I think you now understand that y prime is now the 3 cosine 3x plus 4y, but that whole thing is divided by 1 minus 4 cosine 3x plus 4y. And that now we have it solved for y prime, and that there's no y primes over in our right-hand side. If you have a y prime in your right-hand side and your left-hand side has a y prime, like you have not solved for y prime. So that's always your goal, and that can take some practice. Now, the last one over on for D, your first thought is probably to use what rule? Well, I didn't hear you because you're on a video, but I'm going to assume you were thinking quotient rule, and for very good reason, because you see that you are dividing by y plus x squared. But something that I want you to see is, because you have this equation now, this is not explicitly solved for y, you can do anything you want to both sides of the equation. So you may notice or see that what is a really good thing to do is to multiply both sides by the y plus x squared. Now, it's not necessary, but a lot of students would prefer the product rule over the quotient rule. And so it's up to you. It is up to you, but that's the way I'm going to do it. So now when I take the derivative of the left-hand side, I get 1 minus, and we keep seeing that y cubed, 3y squared times y prime. Don't forget your y prime. And then I'll use the product rule here. Now, another option would be to multiply it out, of course, and then just take the derivative of each piece. But I'm going to use the product rule. So I'm going to take the derivative, so I'm going to see this as one piece and the second piece here for my product rule. Derivative of the first is just 1 times the second, y plus x squared, plus the first, x plus 2, and then I need the derivative of the second. And that's going to be something, because the derivative of y is not 1, it is y prime, and the derivative of x squared is 2x. So now I've got, a lot happening here. 1 minus 3y squared y prime. I've got y plus x squared, and then I've got x y prime plus 2x squared, so I'm just multiplying it out, plus 2y prime plus 4x. And I need to do that. I'm just always checking here to make sure that I got what I need. And there we go. And so now we have a lot of y primes. So notice we do have a lot of y primes here. You can do maybe a little bit of simplification if you want. 3y squared y prime. You may notice I'll just kind of, what am I going to do? Just one quick thing, this x squared and this 2x squared does combine to 3x squared, so there wouldn't be much of a reason to leave those apart. Just going to make sure I have everything here. Whew. Okay, so now just like before, what I'm going to do is I'm going to bring everything that is not y prime to one side and everything that has a y prime to the other side. So I'm going to have negative 3y squared y prime. I'm going to subtract the xy prime from the right-hand side. I'm going to subtract the 2y prime from the right-hand side. Looks like everything. And then on the right-hand side, I'm going to have the y, the 3x squared. I'll have the 4x. There we go. And then I'm going to have to subtract that 1 from the left-hand side and bring it over. So I have this. And then basically, as you can probably see, I'll just write the answer here just due to space, but I'm going to have that numerator y plus 3x squared plus 4x minus 1, and then my denominator is what I'm going to get when I factor out that y prime, and that will be a negative 3y squared minus x minus 2. So again, I'm just going to double check my answer with what I have in my notes to make sure that I don't have to do this video again, and I don't, because it's right. So there, again, we have solved for y prime. So everything on the right-hand side, no y prime, only y prime on the left. And arguably, the y prime can be on the left or the right, but it has to be by itself. And that can be the only y prime that you have. So there's one more problem, so let's see if we can get it. Okay, so this last problem is to use implicit differentiation to find the slope of the tangent line at the given point. So a key thing that I want you to see here is our job is to find the slope. And the slope is a number. So we don't have to spend as much time solving something for y prime. Once we take the derivative, we can just plug in the point that we're being given. And even if we were only given x, we could still find y just by plugging it in. but we don't have to solve for y prime because that's usually one of the most challenging parts. So to take the derivative, I'm going to have 2, keep that on the outside, it's a constant, and then I'm going to have 2 times x squared plus y squared to the power of 1, because I'm using the chain rule here, and then the derivative of the inside, 2x plus 2y y prime. And that is, make sure I have enough parentheses there, like that. For the second side, I can pull out that 25 if I want. I don't need the product rule or anything here. These are just constants. 25 is just a constant, so no need for the product rule. Take the derivative of the inside, 2x minus 2y y prime. So my point is that now we can put in that point. We don't need to spend a ton of time solving this for y prime right now. We can just do it when we have numbers, which will be easier. So we're going to have 4 times, so that's 2 times 2, and then I'm going to plug in my value. So x squared now becomes 3 squared, which is 9, and y is 1, and so y squared is 1. And then we have 2 times 3, which is 6, and 2 times 1, which is 2, and don't forget my y prime is still y prime. Over on the other side I have 25, 2 times x is again 6, and 2 times 1 again is 2. So I have this, and then it really just becomes solving for y prime and getting your number. So this is going to give me 4 times 10, which is 40, and then I have 6 plus 2y prime. Over here I have 150 minus 50y prime, 240 plus 80y prime, and at this point it's really just about combining the y primes and combining the constant. So I'm going to subtract 150, I'll bring that over here, I'll subtract my 80y prime, bring that over here. This is not going to be a pretty number, but that's okay. So we get 90. Over on the other side we get negative 130 y prime, and y prime equals 90 over negative 130, y prime equals negative 9/13. So that truly is, if you were to graph this equation right here, which I don't know what that looks like, but if you were to graph it, what you're going to see is that at the point 3, 1, you'd have a tangent line that would have that slope, negative 9/13. And we just needed implicit differentiation to be able to get it. So that is the end of part 2.